All right. Yesterday we discussed volcanoes. There are two different types of lava flows, Pahoehoe and Aa, and then three different types of volcanoes, a shield, cinder cone, and a composite volcano. Today, people asked me what lava underwater looks like. So if you want to see a quick clip here of what it looks like. I'm not going to play the whole thing.
My name is Joe Reesing. I'm at the Joint Institute for the Study of the Atmosphere and the Ocean at the University of Washington. I was the chief scientist on this expedition, so I led the cruise and the trip to the West Mata eruption. The video that you'll be looking at is large magma bubbles. They're about 3 feet across, and the bubbles are molten rock that are expanded under the gas pressure of magmatic gas. And the magmatic gas, we presume, is mostly water. And when the water is under the magma, it's at magmatic temperatures, thousands of degrees. And when it's suddenly cooled by coming in contact with seawater, the bubble bursts. So what excites me the most about this volcano...
All right. You can watch the rest on your own when you're going through the slideshow. So, volcanoes. What is happening with these volcanoes? Well, first of all, take a look at this picture here. We have a magma pocket down here, and the pressure is forcing the magma up, but the magma doesn't always have to come out of the top of the volcano. The magma sometimes melts the bedrock and goes in a different direction and bursts out in different places, and we call those places fissures. The fissures can be back here. They can be a half a mile away. They're all being fed by the same magma pool, but they've just broken off in different directions. Like a fissure could come from right here and go, magma could come from here and a fissure can rip open here. So all magma does not have to come up from the top of a volcano. It can come from different places. All right, so one of these places was on Kilauea, in the Big Island of Hawaii, in 2018. Over 18 fissures opened up. Maybe it was between 18 and 20 fissures opened up on Hawaii and the Big Island. And you have to remember, the Big Island of Hawaii is made up of 5 volcanoes. There's nothing else but volcanoes there. 2 of them are no longer active, but 3 are active. So everyone living on Hawaii is living on an active volcano. And Lalani Estates is a neighborhood where this fissure opened up right in the middle of the neighborhood and lava started coming out of it. It's opened up and lava. So this video is just showing you that there were some earthquakes that happened that warned scientists that something was happening.
Made ground open up and unleash scalding jets of steam. Then, at 10:31 a.m., a powerful earthquake. This one rating 5.0 on the Richter scale. Matt Page and his family can't feel the earthquake. They're taking a helicopter ride to view the island's most famous volcano, and they're about to get more than they bargained for. Suddenly, a boiling cloud of steam and ash burst thousands of feet into the air.
Okay, so I'm not going to play the whole thing, but volcanoes, unlike earthquakes, give warnings. Their warnings can be minutes before the volcano erupts. They can be weeks or even months, but there are warning signs. Little earthquakes are a warning. An ash cloud is a warning that a volcano is going to erupt. A lava lake that was once solidified starts to go down and starts to liquefy again, become lava again. That means there's some volcanic activity happening. So what's going on? This is the same thing that I was just talking about.
plate, one that does not see much in the way of seismic activity aside from a few stress faults. However, the collision zone between the North American and Pacific plate along the west coast causes a lot more in the way of earthquake action. This all takes place along the San Andreas Fault. Now on to where the real action is, way out west in the middle of the Pacific. Looking at Hawaii on a map, it is located in a pretty good spot, right smack dab in the middle of the Pacific plate. Not a collision zone in sight. So what is causing the earthquakes and volcanic eruptions? Hawaii is not only unique in its beautiful scenery, but geologically as well. You see, the island chain has been formed over millions of years by being located right on top of something called a hot spot. Basically what this is a weak spot in the Pacific plate, allowing magma to make it to the surface, slowly oozing out and creating island after island in the chain. As the plate has slowly migrated northwest, a different location moved over the hot spot, hence why the Big Island is the newest in the chain and also the only island with active volcanoes. The type of volcano is also important. It's called a shield volcano, one that is broad and domed with slow eruptions. Volcanoes are very unpredictable, and no one knows just how long this may last. What we do know is that the Big Island continues to grow, and more eruptions in the future are certainly likely. That lava pouring out of the earth is no joke, but how hot is it? How about 2,100 degrees? Enough to incinerate anything it comes in contact with. Let's compare. A lightning bolt is 50,000 degrees. The surface of the sun, right around 10,000 degrees.
All right. So I cannot pronounce the name of this volcano. And if you want to see a bunch of newscasters trying to pronounce the name and not being able to, you can click here and watch this video. But I show you this because when this volcano set off warning signs, which was this huge ash cloud. This is in Iceland. This is an ash cloud, and inside of the ash cloud, it's very thick. There's a mixture of rocks, minerals, volcanic glass, and hot cinders. And what happened was it stopped airplane travel for weeks from Europe to the United States to Europe. Everyone was grounded where they were. If you were on vacation, you got an extra 2 weeks vacation. If that ash gets into the airplane motors, they will stop and the plane will go down. If you try to fly through it, you won't be able to see anything. It's very dense, very thick and hot material. And pretty much I'm going to call this tephra from now on. So tephra is volcanic fragments that are hurled into the air. So it's solidified lava, it's ash, and it's hot cinders. All right, so if you see this ash cloud or a tephra coming out of a volcano, you know that the volcano is active. So this is what I was just talking about. Tephra is something you should know. Volcanic fragments that are hurled into the air, ash, solidified lava, hot cinders are all tephra. So pyroclastic flow. So if you've heard of Pompeii in Italy, that is a pyroclastic flow. What happened to them was this tephra is now no longer going up, it's coming down, and it can go down the mountainside faster than a car, 50, 60 miles an hour. You can't outrun a hot pyroclastic flow. And if it comes over you, you are going to die instantly. It's hot. It's not even the lava. It's just the ashes are so hot and they engulf you and they're dense. You can't run from it. You can't breathe. If you try to inhale it, you're going to have some kind of lung problems, lung disease. So this is a video here that you can watch about Pompeii. Or here. I'll click on it for a second, but I'm not going to keep it on.
Something triggers a pyroclastic flow about 10 times bigger than all that came before. Within moments, it overwhelms the valley.
See how fast it's going? And this man, he's running faster than a fire truck here. They know that their lives are in danger. If that ash cloud touches them, they're done. If that pyroclastic flow touches them, they are dead. There were people there.
By the time a TV camera in the village records this scene, Maurice, Katya, and 41 others are dead.
Okay, I'm sorry. So that wasn't about Pompeii. That was about a pyroclastic flow. For this slide, I wanted you to know that converging plates will give you volcanic island forms. So you can see here, 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 here. You can get these island arcs from the subduction zone. So one plate is going underneath the other and it's forcing magma up and it's pushing up these volcanoes here. Hotspots. You need to know what a hotspot is. So I will try to explain it the best that I can, and then I will click a video and see if that helps as well. So basically what we have is a magma pool here that is pushing magma up, right? The plate, now let's talk about Hawaii. So this is the Pacific plate. The plate is over the magma. So this is not a volcano like we normally think of. A hotspot does not move. The plate above it moves. So basically, this island that's forming right now, this volcano, is being fed from this hotspot. When the plate moves, this island and this volcano will move this way. So this one will be over here and now become inactive because it's no longer being fed by this. A new one will form. So as the plate moves, you get more islands. So that's how Hawaii was formed. So this one over here, these are the oldest islands, and these are now inactive volcanoes. They're not volcanoes anymore. Neither is this one, this one, this one, this one. The big island is over the hot spot. And like I said before, there are 5 active volcanoes on this big island that are being fed from this hot spot. There's also another island that is growing now in the ocean. It'll take hundreds of years for it to build high enough to be above the surface, to break the surface. But there is a new Hawaiian island being formed right now as this plate continues to move. So we can tell which direction the plate is moving because we know that the hot spot is here, the oldest island is here, so they must be moving in a northwest direction. Again, this is the youngest, this is the oldest. It's moving over the hot spot this way. So the next island will be here and then another one here. So it's moving northwest. So here, this is just a quick little animation. Maybe this will help.
A hotspot is a particularly hot part of the mantle that causes rocks to melt, producing magma. The magma rises up through the crust and forms a volcano. As the plate moves, the volcano is carried away from the hotspot and becomes inactive. A new volcano can now form above the hotspot. Over millions of years, a long chain of volcanoes can form. The oldest volcanoes in the chain are located furthest from the hotspot. The Hawaiian Islands are an example of a volcanic island chain created by a hotspot. The active volcano of Kilauea is currently located above the hotspot, and a long chain of extinct volcanoes stretches out in the direction that the plate is moving.
All right. So hotspots are something you should go over a couple of times so you understand it. And this here is not supposed to be titled hotspots. I just wanted you to get a feel of how close these scientists are. So Scientists, of course, study volcanoes. If they didn't, we would know nothing about them. And they study the lava and the makeup of the lava and whatnot. And some scientists have become so comfortable with volcanoes that they've lost their lives. They forget that this material that they're working with is it's unpredictable. So one moment you could be standing on something hot and something solid, and the next moment it's liquid and you fall through, and that's what happens a lot of times. Not in these cases, but I wanted you to see how close. This is a very interesting one that I'll let you watch on your own. This one's about a minute, so I'll play it.
The bottom of Maroon Volcano is one of the most spectacular places in the world.
This would not be me.
At the same time, it's also one of the most dangerous and difficult to get to.
That is an ocean of lava. An ocean of lava. No, that I would not be there. See him down there? How close he is? Lava is unpredictable. It can jump up and... Nope. No, thank you. Alright, so you can watch this other one on your own. And then this is your science website. You have a page for volcanoes. It's already hooked up. It's already ready to go. Alright, so just remember... You need to know tephra, you need to know about hotspots, you need to know about pyroclastic flow. So go back, figure out what those are, and then do your homework. Have a good day.